forced to study whatever, and we'll let you go and do that. Okay, so here's the deal. We're going to start learning how to graph sine and cosine manually today. You always found this? Everybody? All right, so we're going to start learning to do that, but we're not going to do it the way I'm about to show you. I want you to see why sine and cosine look the way they do, but it is a very tedious process. So what we're going to do is learn some characteristics or some patterns of sine and cosine, and then when I really start uglying up these trig functions, because right now we're going to start graphing this. Y equals the sine of x. Very basic. But what we need to be able to do in the end is graph stuff like this. -2 minus 5 sine of 3 pi, maybe not 3 pi, maybe 3x minus pi over 4. We need to be able to know how to graph that. But that's going to be really awful to graph if you're plotting points like you do on a function. If you don't know what a function is, you know, when you start plugging in stuff for x to get the y's, very ugly. But this we can do. So what I want to show you is how you can graph, and we're going to learn some characteristics of the sine and cosine. And then once we know those characteristics, we'll be able to graph this, because we already know a lot of stuff about shifts and reflections and stretches. And we'll talk about how that behaves the same way an ugly parabola might behave, right? Like graphing a y equals x squared, not too tough to plot points. But graphing a y minus 2 equals -3 x minus 5 squared, a little trickier plotting points, so we learn patterns about shifts. So that's what we're going to talk about first, is what a sine curve really looks like. Now, if you know your unit circle, you can sketch these, but you don't want to do it this way. I just wanted to walk you through one of them so you could see that, hey, I'm not making this junk up. There really is a rhyme or reason to it. Now, what does this x stand for in this equation? Right, but on a sine curve, you're sining what?
The angle.
An angle. So this would be angles you'd be plugging in there. And I don't put theta because I don't have a theta axis. I have an x-axis, right? So I'm calling that x, that y, and y would be what? When you sine an angle, what do you get?
The sine.
Hold on, what do you get?
Or the ratio.
You get ratios. So let's use the unit circle to do this. So I'm going to go through my unit circle angles and what values I get. So let's start with like 0 degrees. So remember, these are angles I'm plugging in. So I'm thinking unit circle. So if I plug the 0 in there, like 0 degrees, when x is 0, what does the sine of 0 degrees give me?
0.
Yeah, I'm going with the y value there would be up nothing, right? Some of you struggled a little bit on your test on those unit circle values. I mean, most of you had an idea, but a couple of you memorized tangent as x over y. That's troublesome. But right here, so make sure you know your unit circle moving forward. But on this one, we're going to learn patterns. We're not going to have to do this. So the sine of 0 is 0, which means when x is 0, y is 0, there's a point on my graph. Now, what's the next angle that you know on your unit circle from 0? Moving up. 30? Okay, 30 is like pi over 6. But I'm going to be using radians here. So if this is pi, this would be pi over 2, right? This would be pi over 4. Pi over 6 is actually breaking this pi up into 6 parts. Are y'all with me on this? So if this is pi, breaking it up into 6 parts would be like breaking it up into half and then breaking this up into thirds. So this would be the pi over 6. This would be the pi over 3. There's the pi over 2. There's a 3 pi over 4. Stop me at any point if I'm losing you. This would be the 2 pi over 3, and that would be the 5 pi over 6. Is that kind of making sense? 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, or pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Are y'all seeing that? So I'm taking these values and I'm putting them on here. Now let's jump to pi over 6, which is like 30 degrees. What is the sine at pi over 6 or 30? A half. So at pi over 6, I'd be up a half. You know what? It'd be a lot better if this thing was a little bit higher. But there's my pi over 6. I'm going to go up a half right here. Okay? Now, because that's 1. So I'm going up a half. Now, what happens at pi over 4? What's the sine at pi over 4? Square root of 2 over 2. Anybody know what square root of 2 is? About 1.4. So what's the square root of 2 divided by 2? What's 1.4 divided by 2?
8 or 0.7.
About a 0.7-ish. So right here, I'd be up at, that's 0.5, I'd be up at about 0.7-ish. You with me? So there's my 0.5, there's a 0.7. Now I get to pi over 3. What happens at 60 degrees? That'd be root 3 over 2. Anybody know what a root 3 is? It's about a 1.7. What's a 1.7-ish divided by 2? About a 0.8-ish, right? So it's actually like 0.86, something like that. So at right here, I'm going to be at about 0.8-ish. And then finally, what about pi over 2? At 90, what is sine? 1. So now I'm up to the right here at 1. And then what happens at 2 pi over 3? Now I'm coming down the other side. What's the sign there? Square root of 3 over 2. So still about 0.86. So we're about right here. Same value as that. And then what happens at 3 pi over 4? Root 2 over 2, which we said was about a 0.7, right? Or 1.4-ish divided by 2. So that puts me about right maybe there. And then what about at 5 pi over 6, 150 degrees? A half. So a half puts me there. And then what about at pi?
1, 0 again.
The y value, these are all y values, right? Back to 0. So it puts me right here. So this sine curve, I only plotted the ones I knew, but there's other angles too, right? I just don't know they're just not special, so I don't know their values, but a calculator could have given me all those. And if I connected all of these dots, you see this sine curve doing this. And it took all the way to 180 to go through all the positive values, didn't it? Now what happens in the next 180? They're negative, but they're really the same absolute values. They just have negatives on them, right? So what do you think this next pi is going to look like?
Like a loop on.
Same thing as that going down. Do we really need to go through all those?
No.
I don't think so. It's painful, right? So it's going to, but also I'm going to plot those and it's going to bring me down here. Now, once I get to here, which again, 2 pi is the same thing as 360 degrees, same location. What is going to happen again? It's going to repeat it, isn't it? So just like pi over 6, which was like my 30, 30 here is going to be the same thing as you have at what? 390, right? 30 degrees further. So this represents what we talked about yesterday, the period of the graph. And what do you think happens if I go this way? Yeah, because this would be a negative 30, and the sine of a negative 30 is the same thing as the negative sine of 30, so negative 1/2. And you see the same values. There's pi. You see these you see these values come through here and then back through here. So you see this sine curve rolling along and rolling along. Well, what I want you to understand is every time you graph a sine curve, there is a period to it. And on every period, there's a maximum height and a minimum height that it moves up and down. There's a length to this period. There's characteristics that I want you to understand. Also, this graph doesn't have to start at the origin, just like a parabola that y equals x squared starts at the origin. But if I shift it, it may start up here, right? So what we're going to have to do is figure out about shifts, reflections, maybe if it's flipped, but all of those things are very similar to what we already know about the basic functions being shifted. So the biggest take from this is this. You need to be able to look at a function, a trig function, and figure out its period. And once you figure out its period, what I want you to do, everybody with me on this? I want you to find the period, find the length of it, whatever that is, and I'll give you a little, we'll see a formula for that. And what we're going to do is we're going to draw period. We're going to draw what we call the box. And the box is a big rectangle, right, that goes around the sine curve. Now, again, I'm not even going to have the sine curve in here at this point. Okay? But what I'll do is I'll figure out the length of this period, and I'll know where I'm supposed to begin, and I'm going to mark off this big box. It actually looks like a rectangle with something going through the middle. Okay? And then rather than plot points, again, pretend there's nothing on here. I'm going to find this period, okay? And I'm going to draw a big rectangle. Also, not only am I going to know the length of it, I'm going to know how high and how low. And that's pretty easy. I'll show you in a second. So I'll have the length of it. I'll have how high and how low I'm going to be. I'll know where my shift up and down is or left and right is. All these things we'll know, and we'll use those to sketch what we call a box. And sometimes the box will look kind of long like this because the period is long. Sometimes the box is really tiny, but it doesn't really matter. Whether the box is long, tiny, skinny, doesn't matter. What we're going to do is say, all right, once I have the box, I know that every sine curve is going to start right there in the left middle side of the box, and it's going to end in the right middle side of the box, and it's going to have a bump up and a bump down, or possibly a bump down and a bump up. We'll talk about that as well. And what you'll do is you'll identify all this stuff, and you'll go, all right, if there's a bump up and a bump down, then it's going to cross this middle line again, where? Right there. And then you'll say, well, if it's bumped up, you go halfway up. If it's bumped down here, you go halfway down. And once you have these 5 dots, you'll just sketch the curve through them. And sometimes and if you need to graph another period, you'll create another box and do the dots and connect them again. And that way we don't have to plot points. And what you need to understand is whether the box is long and skinny like that, or whether it's even like this. If that's your box, once again, you'll go, okay, sine curve starts in the middle of this side, ends in the middle of that side, crosses this again in the middle, and then halfway between these 2 dots, I'm going up. Halfway between those 2, I'm going down, and I'll connect the graph. And all of this, the lengths of the box, the heights of the box, where you mark the box, those will be things that you can get. It's not difficult, but it's important that you find these things, which we'll talk about in a second, sketch this box, and then know what a sine curve looks like. Because once you get this box, a sine curve is going to look different than a cosine curve. And it'll be slightly different with tangent and cotangent, secant and cosecant. But some of the same basic principles are there. But ultimately, remember, why does the sine curve look like it looks? Ultimately, not because of the little tricks I'm about to show you, but because what?
The function.
It's a function. And you're just plugging in x values, right? And like any function, if I'm like, why does a parabola look like this? Well, because when you plug an x in, it spits out a certain y. And it just happens to have that shape. So this is the general shape of a positive sine curve. What do you think happens if I make it negative? Yeah, you go down first and then up, which makes sense, right? Because these are y values. So instead of getting positive y values, if I have a negative up front, I go down first, I get negative y values. And then I'm negating the negatives, which make those positive. So all these things we're going to talk about, you shouldn't have it shouldn't be a huge deal once you get the hang of it. And we're going to do it today. We're going to take a break on Monday when I'm not here. You're going to work on your exam review again, right? Then we'll come back on Tuesday and we'll talk about the other trig functions. Then we'll come back on Wednesday and we'll talk about how to actually look at graphs and figure out the equations. We'll kind of be going the other way with our train of thinking. And after 3 days of it, I think you'll all be in pretty good shape. Then we'll review and move on. All right? So that's the idea. Now, we're going to only talk about sine and cosine today. Cosine would be very similar to this, except check it out. With cosine, and I'm not going to do a bunch of them, but if I had a cosine of x, what happens when I plug 0 in the cosine? What's the cosine at 0 degrees? 1. So I'm up at 1. I'll just do the pi over 4. What's the cosine at pi over 4? We're at 45. Root 2 over 2, which is about a 0.7. What's the cosine at pi over 2? 0. Straight pi over 2 would be 0. That's half of a pi. What's the cosine at 3 pi over 4? Negative root 2 over 2, right? Which would be about negative 0.7. And what's the cosine at pi? Negative 1. Can you see how the cosine is going through these values? And you learned what? Cosine was positive in the first quadrant from 0 to 90. It was negative in the second and the third, right? From 90 to 180 and 180 to 270. And then in the fourth quadrant, from 270 to 360, it was back to positive again, wasn't it? And what hopefully you'll know about cosine is you'll set the problem up the exact same way you did sine. Instead of doing this, what you're going to be doing is going, all right, I figured out how long the period is, so you'll know how long it is. You'll figure out how high or low to start it. You'll figure out how high and low it goes from that starting point, and you'll come up with all of this information that we call the box. And it'll even have this part in the middle here. So you'll get this box, and it might be long, it might be short, it might be tall, it could be anything. But once you get the box, you'll have to remember that cosine resembles this shape in any box we make. So what you'll do is you'll go, well, I remember, pretend this is not there. You'll say, I remember that cosine starts high right there in the corner and ends here. But it dips down in the very middle. So you'll find the middle and you'll mark it down. And at some point it has to cross in between this, right? It crosses into between there, in the middle here, and in the middle there. And you'll get this and you'll go, well, looks like I've got a cosine curve. And you'll come in here and you'll sketch that cosine. And if you need another period, you'll mark another box. But it doesn't matter. Your box might look like this. Like you might sketch your box out, and it might look like this based on the information you're given. But you won't be deterred because you'll go, that sounds a little off. You won't be misled because you know that cosines start high and end high. They dip down at the bottom, and they cross this line somewhere in between, right in the middle, in between there, right in the middle there. And you'll come in here and you'll go, oh, so there's my cosine curve. You tracking with me? So that's the goal, is can you find the shape of your box? And then can you remember that positive sine looks like that and positive cosine looks like that? And if you get that, you're home free. And there are some things you got to memorize. And also, I realize that some of you are artistically challenged. Like Hill, I don't know if you've looked at Hill's right? It's absolutely terrible. I mean, it's like when he signs his name, it's Hill, and then after the next H, it looks like a cardiogram or something like that. He actually, on his test, he wrote H-I, because I always give him a bad time. I'm like, Hill, but anyway, I had a kid named Charlie Vaughn, way back. Brilliant kid, went to Stanford, and his brother was another brilliant kid, went to Duke. I mean, really bright kids, worst handwriting on the planet. It was like, Charlie, draw 6. Charlie, draw 4. Charlie, draw 9. I mean, everything looked the same. But because he was really bright, I was like, oh, okay. I kind of got, well, when it came to graphing trig functions, it was a mess. Like, he would get his shape drawn. Of course, it wasn't. It was more like this. When he drew his box, it'd be like, and then it would get to the sine curve, and it'd be like, I mean, it was the worst looking thing ever. And I was like, dude, you're killing me. I know you're bright. I know you're there. And that's where I came up with the little dots. I was like, just put the dots in the right spot. So he would come in here and be like, okay, if he had it right here, he'd go, all right, dot. He could do this, dot, whatever. And then it'd be like, still, whatever. But at least I was like, okay, you have no motor skills, but I do know that you know where you want to go. Good enough. Okay, so try to do your best on that. Most of you guys actually have pretty decent handwriting. But let's talk about how you determine how the shape of this box plays out. Okay, now you've got great notes on this. Well, I think great notes, but they're over here starting on your page 67. All right, so starting on page 67, let's check them out. So first thing you need to know, you can see right here on sine, cosine, negative cosine, I have put a box in there. Do you see it? And you can see the same thing we just talked about. The sine is always going to have that shape. So once you get your box, make sure you have these 2 points on the ends, this one directly in the middle, and then this high one directly in the middle of that, directly in the middle of that. I'm looking for that. And then once you get those 5 points, do your best to connect. I mean, try not to zigzag and make Z's. I mean, they are curves, all right? So do your best, but if you've got the points there, I'm going to be very lenient on your ability to curve a line. Cosine, like we said before, again, you're going to have to find this box. Might be big, might be small, whatever. You're going to go high, high, low, dead in the middle, and then right in the middle of these, those are the points there, connect your dots. And I'm normally going to have you sketch 2 periods. So once you do a box, you're going to do another box identical to it on either to the right or the left or wherever you can fit it in. Okay? Now, how do you figure this stuff out? So the first thing you need to figure out, I have all these notes at the bottom. The first thing you need to figure out is, am I shifting up or down? Now think about a function like y equals x squared. If I had a basic function like y equals x squared, what determined up and down? Something outside? So like if I went plus 3 on the outside, you would know to shift it up 3? Well, the difference between this and a trig function is we don't usually go plus something on the outside there. And the reason why is for younger mathematicians, sometimes they accidentally add it to the c. So with logarithms and other things, so that people don't do that, they kind of, with trig functions, stuff like that, they put that number that I'm adding right there. But that d is my shift. It'd be kind of like me writing this 3 plus x squared. We just don't write it that way. But it means I'm going to take the parabola, add 3 to everything, and it's going to move it up. So the first thing you're going to identify is whatever that is. So if that d, that number right there is 4, instead of marking it right there at 0, you're going to go up 1, 2, 3, 4. That's going to be the middle of your box. Are y'all with me? So this is the shift up and down. And it's the shift right there in the middle. It's going up or down. We'll do a number of these, so you'll be fine. Okay, the next thing you're going to deal is the amplitude. Now, the amplitude is how high and how low I go. So if my amplitude is 2, that means from this middle, you're going to go up 2 or down 2. All right, that's kind of like your stretch, right? So like you remember on a parabola, you normally went 1, 1, right? But if it was a 3x squared, you'd go 1, 1, 2, 3. So it just triples the height of every y value. Well, on this one, you've got y's going up and y's going down. So it triples the ones here, triples the ones there. Well, all we need to do is just triple the height of my box. So if my height was 1 and there's a 3 there, now my height is 3. But it's going to be the height up and down from here. So the first thing I do is find that d value. That's what's going to be the middle line. Second thing I'm going to do is go to amplitude. I'm going to go up a and down a. And the reason why I said absolute value is if this was like -4, don't say the amplitude's -4 because the amplitude is like a height above and below. So it's kind of like a distance. So we always say it's the absolute value of that. So whether it's positive or negative, we would say 4. Are you with me? But that's the height above and below the vertical shift. Now you've got the top, middle, and bottom of your box. You with me? So the last 2 things I need to find are, where's my shift this way? Now my shift this way used to be stuff like this, right? X minus 2 squared, I knew I would go 2 to the right. Are you with me? But never did I ever give you a parabola that was like 3x minus 2 squared. I never did that, did I? Right? I never had a 3 right there. But if I did, your shift would not be to the right 2. It would be to the right what?
6.
2/3. And I could find that by taking that number there and solving. Now, I didn't have to do that here because if I take that number and solve, I always got 2. So I would say, well, if it's negative, go 2, go to positive 2. If it's positive, go to negative 2. But what I'm really doing is just taking that and setting equals 0. So for you to figure out where I'm going to have the left part of my box, where I'm going to kind of begin the box, I'm going to take this and I'm going to set that equal to 0 and I'm going to solve for x. Now I wrote it was c over b, but a better thing you might want to do is just take the bx minus c, whatever it is, set it equal to 0. And whatever you get, that's where you go to get the left side of your box. So if it's positive when you solve, you go to the right. If it's negative when you solve, you go to the left and you mark that edge. So now that's going to give me this right here is that c over b, whatever I get. So now I've got the middle, the top, and the bottom, and this side. So the only thing I'm missing now is, where's the end of the box? Well, the end of the box is the length of the what? Of the period. It's the length of one period of the graph, whatever the graph happens to be. The trick for doing that is going to change from sine and cosine and tangent and cotangent. And then when you come back and do secant and cosecant, because they're reciprocals of sine and cosine, they'll have that same period. But the period on this thing was 2 pi. But the reason it changes, it's not always 2 pi, it's 2 pi over whatever the b value is. So on the graph we did, the b value was a 1 because we were doing sine of x or cosine of x. But now we're going to go 2 pi over b. So the last thing we're going to learn is we're going to just take the 2 pi, and all of what we're going to do is going to be in radians. 2 pi divided by whatever that b value is. I'm going to get some number, and that's going to represent the length of the period. So on this particular one, if the length of the period was 2 pi, then I go from here over to 2 pi. If the length of the period was 3 pi over 2, which is like a pi and a half, then I'm going to go from here to a pi and a half. If the length of the period is just pi, then I'm going to go pi. And that's going to give me shorter or longer periods, just depending on what my b is. And that's going to give me the end of the box. And once I have the end, if it's a sine, do this. If it's a negative sign, do this, right? Sine, negative sign. If it's a cosine, do this. And if it's a negative cosine, do this. And you see that in these pictures too. And I threw a lot at you. Let's see if we can put it together. And don't worry about if you have to check your notes a lot starting out. And just go in this order. You don't have to necessarily, but that's what I do. You'll be in pretty good shape. So check out. I'm going to page 71. We're going to do the first one. So what is the first thing I want you, or suggested that you guys do? In that box of things to find. The vertical shift, which is the d value. What is the d value here?
2.
The negative 2. So what you're going to do is go negative 2, basically drop down to negative 2. So here we go. I'm putting a dotted line to represent my d value at negative 2. And what does this dotted line represent as far as your box is concerned? It's the middle of it. It's that middle line of the 3 horizontal lines. So that's the d value. All right. And by the way, once you've dealt with that, you're not going to use that again. So move on. Now, the second thing I wanted you to do is do what? Find the a value, and the a value represents what? How low or how high I go from this. So what is that a value?
4.
And is it 4 because it's plus 4, or is it 4 because it's that number sitting in front of sine? Yeah, because whether it's negative or positive, it's 4. So the a value, since d was negative 2, your a value is 4 because absolute value is 4. I'm going to go up 4 from d, not from the old x-axis. Forget about the old x-axis. And I am going to go down 4 to here. So I'm going up 4 and down 4, and I'm going to draw dotted lines there. And if you wonder why I'm drawing dotted and not solid, is because technically when you're graphing, a solid line represents the graph. And this is not part of the graph. It's just helping me sketch the graph. And if you don't want to put your dotted lines all the way across, you don't have to, because you are only going to have to put 2 periods in there. My keys will have the entire thing filled out, I think. But you only have to do 2 periods. All right, so we'll see if that makes it harder or easier. We'll see. All right, so that takes care of the 4. Now it doesn't, I still have to think about that positive and of course the sine, because I'm going to be sketching a positive sine curve in here. But what do I need to find next? The what? I need to find the left part of the box, which is my what? Which is my phase shift, right? Or my, not the vertical shift, but it's like a horizontal shift. We call it a phase shift. Where does this phase begin? And the phase shift we find by taking this and solving, right? So I'm going to take 4x. Now be careful. People mess this up. Set it equal to 0. Solve. I'm going to add the pi over 2. Then what am I going to do? To solve for x. Divide by 4. Now let me show you what people mess up. Sorry, that's not 4 pi. 4x. I'm going to divide by 4. Now let me show you a better way than this. People always do this and mess, not always, but a lot of times mess up. They divide by 4 and cancel it there, but then they get here and they cancel the 2 with the 4 and write pi over 2. Now think about what I just did. If that math is true, I'm telling you that if you take a half of a pi and divide it into 4 parts, you still get a half of a pi. That kind of math doesn't make sense, does it? You know that's not logical. Think about it. If I had a half of a cherry pie and said, hey, you 4, come get a slice, do you each get a half of a pie? So what did I do wrong here? Or what might be a great way to combat that mistake? Much better. He said multiply by a 4th. And if you multiply by a 4th, you'll go, oh yeah, dividing by a 4 is the same as multiplying by a reciprocal. That looks better, and I'm not going to make that error. So what does this represent again? A positive 1/8 pi? I'm shifting 1/8 of a pi. Now where's pi? That's way over here on this graph. Now I might give you a different graph where pi is right here. I might give you one where pi is right here. So I normally am pretty kind. I didn't used to be, but I'm normally pretty kind. So I want to go 1/8 of pi and put a vertical line. So if this is pi, break it up into 8 parts, which look, I conveniently did for you. Doesn't that represent 1/8 of that? So I'm going to go to there and drop in my phase shift. So that is my, right there, that is my phase shift. So I've got D, my amplitudes, my phase shifts. What's the last thing I need?
The stretch.
The what?
How big the period?
How big the period, length of period? And how do I find period? Period is always, now for sine and cosine, and for secant and cosecant, period will always be 2 pi over the b. So 2 pi over the b value, which happens to be 4, all right, that's my b, which gives me pi over 2. Now here's where it gets a little tricky. I'm not telling you, everybody hear this, I'm not telling you that the period ends at pi over 2. Don't just go to there. What I'm telling you is the period is pi over 2. That is the length, okay? Now, this number line is like a ruler, and the number line's units might be different from time to time. In this case, how many tick marks represented pi? There were 8 tick marks, right? 1, 2, 3, 4, 5, 6, 7, 8. How many tick marks represented pi over 2? That's a half a pi right there, isn't it? How many tick marks represented that? 1, 2, 3, 4. So what this means is it's 4 ticks on this ruler. You have to identify that. That will change from graph to graph. So what you do is you go, all right, from here, I'm going to go 1, 2, 3, 4 ticks. And that period, pi over 2, was 4 ticks. That's 1 period. So do you see the box? I'm going to outline it in pink. Here is my box. And you need to graph 2 of these. Do you have room to get a whole period into the right? No. Well, just graph one to the left then. So if that's one box, I'm going to come over here in green and graph another box. Still 4 long, same height, same depth, same middle. And once I have 2 periods, 2 boxes marked off, how do I sketch a positive sign? Help me out. Positive sign starts where?
Starts
in the middle of the left side. Where does it end? In the middle of the right side. Where else does it cross here? In the middle of that. And when you do that, it gives you a bump up and a bump down. Does this one bump up first or bump down first? Yeah. Why up?
Oh, yes.
Because it's positive sign. So it's going to go up and hit the high point right here in the middle of that. And it's going to go down and hit the low point right there. And once you get your 5 dots in there, I hope that it looks decent, but just like Charlie Vaughn, lots of grace, or Jimmy, both of them, lots of grace on this. But you can see that I'm just doing the same thing. I'm putting those dots in and sketching the sine curve. Not too bad. And what was really nice is I didn't have to plug in pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over. I didn't have to do that, which would be awful dealing with that. Finding common denominators and dealing with everything would be just a mess. You could do it, but it would not be pleasant. All right, let's try another one. Look at number 2. I'm going to erase all this. Let's try to go a little bit more quickly in the interest of time.
Are you going to tell us how many periods we have to graph?
2. Yeah. Unless you can't fit 2 in. I mean, if one of the periods, like on this one, here's a pi, right? So what if the period's 2 pi? Well, that's 2 pi right here. I can't get another one in, right? So if you can't get a whole full 2 in there, just fill up the graph. But if you can get 2 in. 2 may, if the period's pi over 2, you might only have a little part right there. But don't let that figure itself out. But always give me 2. All right, first thing, what am I going to do? The D is what? -1, going down to -1, marking a horizontal line. All right, that takes care of that. Next, what's my amplitude? 3, not -3, but it's just 3, right? So that tells me to go up 3 and down 3, not from the x-axis, but from whatever the D was. And I sketch that in there as accurately as I can. It's not a terrible time to have some markers. I realize having markers over this is nice. When you put one of a pencil and you do it, it kind of hides. It's really hard to see it. I usually do this, like if I'm on a sheet of paper, I put my dots just slightly above it so I can kind of see it on my graph, but whatever works for you. If you want to bring markers to this, works great. Or do your homework that way. All right, so I'm done with the 3, but I'm not done with the negative and the cosine. I'll deal with that last. Next, what are you doing? Solving for x gives me my what? So I'm going to subtract the pi over 2, and then I'm going to multiply by a 1/3, and I get what? -pi over 6. Now, that means I want 1/6 of a pi to the left. This is pi. So look at that, conveniently broken up into 6 parts, right? So I want to go 1/6 to the left. That would be my phase shift. So that goes right there, -1/6 of a pi. And then lastly, what do I want? A longest, which is my period. So the length of the period is always what? 2 pi over the b value. Okay, now let's think. What is 2/3 of a pi? Now think about it. Here's pi. 2/3 would be what? From here to there? So can you see that 2/3 is 4 ticks? Now if you need to do this, if you need to go, a pi is 6 ticks. So if a pi is 6 tick marks, I want 2/3 of 6, which is 4 ticks. So think that way if you have to. But it's 4 tick marks. Now, I don't go to 2/3 pi. I do what? From the left side, I'm going to go 4 ticks to the right. So from here, 1, 2, 3, 4, mark it. And that represents 1 period. And then I'm going to do it again, 1, 2, 3, 4. And I usually go to the right on both if I can fit them in.
Wait, is that formula 2 pi over A?
That's 2 pi over b.
Or B?
And remember, you got those notes on that. If you forget, go back and check them out, right? Now, do I have my boxes? All right, so all I got to do now is just remember what a negative cosine look like. What does a negative cosine look like? It starts bottom corner, ends in the bottom corner. So I'm going to mark bottom corner, bottom corner. What does it do? It peaks in the middle. So in the middle, I'm going to go to the very top. And then where does it cross this? Not in the middle and not at the end, but in the middle of the middle, right? So right there and right there. And at this point, try not to give me just a big upside down V. There is a curve. It might help to go ahead and put all your dots in. And then just kind of treat it like a sine curve. Okay, here's a bump up. There's a bump down. There's a bump up. And then there's a half a down and a half a down. Not too bad. You got 6 problems from it. And you got 8 minutes if you want to start now. But all you have to do is go to the, it's page 73. I think I gave you 3 sines and 3 cosines. And again, it might be nice to have a marker or something to sketch your boxes. But that is all you have tonight. And remember, bring your exam review packet on Monday because I will not be here and I didn't want to try to just teach through a video because a lot of the subs have issues pulling my videos up when they don't have access to my channel and stuff. So.